So here's example number 2. So the second example says, Sam takes an 800 milligram ibuprofen for her nagging headache. Every hour that the ibuprofen is in her system, a quarter of the medicine dissolves in her body. These are made-up facts. Always consult your physician or pharmacist before taking medication, and that is always true. And so it says, write a function that models the amount of ibuprofen in Sam's body over time. So first, of course, we look for our initial value, and the initial value, according to our problem, is 800 milligrams. So it says Sam takes 800 milligrams of ibuprofen for a nagging headache. So that's the initial value. Okay, that's going to be our initial value, 800. Okay, so our initial value is 800, and then our multiplier, right? So it says it dissolves in her body. So dissolves means that it's going to decrease. Okay, so this dissolves means like decrease. Okay, that does not mean increase. Dissolve means that it's going to go away. It's going to become smaller in size. Okay, so there's not going to be as much milligrams left. So we are going to, of course, write our multiplier. Again, we always start off with 100%. And then we either subtract or add according to our word problem. Again, it says dissolve, so that means that we are going to subtract from our 100%, from our initial value. So it says that we are going to subtract a quarter, because it says a quarter of the medicine dissolves. A quarter means 25, right? If we think of a quarter, like an actual quarter, like the money, it's going to be 25%. Okay, so then we are going to subtract 25% from 100%. Okay, so let's go down here. The word problem disappears. We're going to go ahead and start writing our exponential function. So it's going to be y equals, our initial value is going to be 800 milligrams. That's how much medication she took. And then open parentheses, our multiplier goes inside the parentheses, and again we are doing 100% minus 25% because our word problem says that it is dissolving, the medicine is dissolving a quarter each hour, I think it says. Yeah, it says every hour. So every hour it's decreasing by 25%, by a quarter. So we put that in here, 100% minus 25%. And then, of course, don't forget your exponent, your variable x as the exponent. Right. So let's go ahead and simplify this. It's going to be y equals 800, the initial, and then 100% minus 25%. That's going to give me 75%. And then to the power of x. So we can see here, if you think about the first example we did, we had a number in here that was greater than 100%, right? Because it was increasing. Here, our multiplier is less than 100%. It's less than 100%. And the reason it's less than 100% is because in our word problem, we're talking about medication, and medication dissolves when it's in the body. So there's going to be less and less of it in your body as time progresses. So that's why this is less than 100%. So we're going to go ahead and finish this off. Remember that we do not like this to be in percent, so we add a decimal and we move it over twice, and then we write the new decimal. So 75% becomes 0.75, okay, as an actual number. So then our multiplier is going to be 0.75 to the power of x. So notice how our multiplier b is less than 1. And it's also, sorry, let me white that out because that's going to bother me. Mistakes. Okay. And it's going to be greater than 0. So our multiplier is in between 0 and 1, 0.75. And so this is an example of decay. Okay, because of that. Okay. So let's go back to our word problem just to verify and make sure that we did this correctly. Okay. All right. Oh, something not good. Sorry. Okay. So let's go ahead and verify that we wrote this correctly. So again, our initial is 800, and according to this, it is 800 milligrams of ibuprofen. That's what she started with, and it decreases, or it dissolves, a quarter at a time. So a quarter means 25%. So that's how we got this 0.75, because it's 100% minus 25%, which equals 75%, and as a number, that is 0.75. Okay, and we have confirmed that that is how you would write the exponential function. So this is your final answer, and this is where we would stop.